All right, friends, welcome. Week 2 of Projects and Algos. I've got a typo here. Thanks, Shane. Just a little bit of housekeeping before we get started. Make sure you guys do your discussion questions. Those are open. Those are available. If you run into the issue where you have done your discussion questions, but it's showing that you didn't, do me a favor. We had 2 students had that issue, but do me a favor, take a screenshot of your submission and then send it to me. And then I can go with the, just to kind of verify. And then I can go to the, I'll make sure I count it. But I'm working with the tech team to kind of make sure, try to figure out what the issue is. So if you ever run into that, just take a screenshot of your submission. It has a timestamp on it, so that's perfect. And then I can go in and make sure that you guys get counted for. And again, if it doesn't show up, but I have that email, that's sort of a time stamped. Nope, this is legit. They did it before the time. Should be good to go. You've got a couple core assignments this week. This week's a busy one. You've got arrays to do, and you have your strings to do. Edwin, I know that you had some questions on strings to do. We didn't get to it this office hour, but we'll try to get to that tomorrow. Kind of walk through some of those questions.
All right.
Cool. That's due Sunday. Hopefully you guys have submitted your solo project proposal. A lot of you guys emailed it to me. That's great. I've marked it on the sheet. If you haven't, and you submitted it, I need to go through and I haven't looked at all of those yet. I've just kept up with the ones that have emailed it to me. Again, this solo project is supposed to be due or is due next week. So usually the idea is the first 2 weeks is your personal project. Obviously, you're going to keep growing in that. This is for your portfolio. So hopefully you keep working on it after the coding dojo. And then the next 2 weeks are your group project. Now, in talking about group project, I'm going to ask if you want to work with a group. I know a couple people are working in a group. You need to email me by end of day Thursday who you want in your group, and make sure that you put everybody, make sure you put everybody that you want, like CC them. So that way, it's just verification. Like, yes, if they say, oh, I didn't want to work with this person, they can email me, right? Not that I'm just putting them in a group and they're like, well, I didn't want this. So please make sure one of you emails me, CC everybody else. And then, I can put you in a group. That needs to be done by end of day Thursday, because on Friday, I will be doing, I will be going through our group project preferences. And if you don't already have a group, if you didn't email me, I will put you in a group by end of day Friday and send out an email. I'm just going to ask, if you don't do it by Thursday, and I put you in a group, I'm not going to switch everybody around. Just do it by end of day Thursday if you want to work with people. It's not a big ask on my part, but please make sure you send that, because what I don't want to do is, make a bunch of groups and then people are like, oh, I want to do here. Just kind of, once I do that, it's kind of finalized. So that'll be end of day Friday that I do that. So end of day Thursday, I need you in those groups so I can go through and handle that. Cool. And the question was asked in office hour, do you need to have everything that you're doing, front end, back end? No, you don't need to have that. If you're wanting to be in a group, you don't need to have that laid out. Just tell me who you want in your group and I'll make sure that I go and I notate that. I will put that here. You guys can't edit this file. I'll go through and I'll do that as well. Cool. Any questions on that? I saw one hand. Benjamin, did you have a question on that?
I did, but I think you answered. I was just gonna ask if we each individually had to email you with our groups, or if we assign like a group leader per se,
Yeah.
and have
Yeah,
that one person email you. But I think
Yeah, as long
you
as
covered that.
Yeah, as long as you're CC'd on it. So if Shane were to send me an email and say, hey, Don Trail and Victoria and I are going to work on a project, but they're not on it, I'm going to have to then go to Don Trail and Victoria and say, hey, is this true? Just CC everybody. That way, and if you get CC'd on one that you didn't agree with, just email me separately and be like, I did not want to, I did not agree to work here. I have another group, or I want something different. That's fine. But they all need to be CC'd. So that way kind of prevents that from happening. Any other questions? Great. Okay, so how it's going to work next week, just a little bit of business, is next week will be our solo project presentations. Now, this is to verify that you have done all that you need to do, that you have the CRUD functionality, you have login and reg if you're in Java or Python, and that you've sort of hit every mark. I will be sending out today or tomorrow. Or not today, sorry, tomorrow or by when. Tomorrow's Wednesday. Yeah. So by end of day tomorrow, sorry about that, guys. I will be sending out a sign up sheet, or I will figure it out. Either I'll put it in this sheet right here, or I'll be sending out a sign up sheet that you can go in and you can sign up for a specific time slot. We're going to do it for office hour and lecture for these 2 days. And I will make it for office hour again on this day. So we'll have basically 5 hours of presentations. Each person's going to get 5 to 10 minutes. I'm going to do 10-minute slots. Hopefully, it is quicker than that. But hopefully we can do that and then you can knock that out. If you try to go sign up for a time that doesn't work for you, your other option is for you to send me a video of you walking through your application, your code, and, kind of proving every piece, yeah, here's my CRUD, here's my XYZ, and then talking about your project, right? Here's what I created. I created a vinyl store. People can create a vinyl, they can comment on another one. You log in and you register. I wrote it in JavaScript, blah, 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 blah. The other portion, and this was also a question, is you do still have to, though you're presenting it, and you have to have some sort of presentation where you are either doing it in class or you're sending me an email or a video. You also have to submit your solo project. So we have to have that on file as well. And so there is a portion in our wireframes section where it says solo project complete. And this is where you can upload, use your GitHub link to your project's repository. So make sure, do you guys see a submission? I don't know that I do because I'm an instructor, but can somebody go to this and make sure?
Yeah, it's on there.
Okay,
it's
cool.
on there.
Yeah, great. So this is where you put your GitHub link to this. I will be going on Thursday. If you're like, how the heck do I do GitHub? Thursday we'll go over just how to throw something onto GitHub. There's also a video right here on next Thursday's video, but there's a Git and GitHub tutorial. So that way, or next Thursday on the 29th, there's a Git and GitHub tutorial in case you're wondering on how to push something to GitHub. I think it's here too. Yeah, same thing. Cool.
Get in it.
Yeah. Okay. Any questions on that? Again, the idea behind the sign up sheet is maybe you work and so office hour, you can't ever make it there, but you can come during class. That's when you can go sign up. So I'll let you know when that's live. And then you can kind of handle that and go make, and again, if a time doesn't work, just shoot me an email. Hey, this doesn't work. I'll be sending out a video and then I'll say, okay, great. So go ahead. I see a question.
Yeah, so the algo stuff. So is that do you on yourself a thing, or is that like something we had to practice in class?
The arrays to do and strings to do?
Yeah, most of the algo stuff.
No, that's what we're talking about. Singly linked list today. That's all the lectures other than these, which we're going to already talk about. You can see that these are the same. We're doing algos in class during lectures, except for these 2 presentation days. But we'll do, we're going to talk about recursion on the state.
Thank you.
Yeah, of course. Great question. Anybody else? Okay. Today we're talking about singly linked lists. Singly linked lists are a way that we can store and save data. And it's a quite popular way. There's a lot of different reasons for that. But it's a way that we can store and save data. Hold on, let me. Tommy, can you lower your hand? That'd be great. But it's a way that we can save data in a unique way that's different than like an array or something of the nature. So let's go to our platform. And this is after the string section. You should see a singly linked list. Now, again, it's a data structure that allows us to store data, but in a specific way. And when we're really dealing with it, there's something I think that's a little bit important for you guys to understand. And that's how in memory, a array, and when I say array or list, I'm going to be talking about a dynamic array or list. Static is a little bit different, but how a dynamic array or list, they're the same thing. One's Python, one's JavaScript, is actually stored in memory. And then we can kind of see the power behind a singly linked list. Okay. So let's pretend that we've got this. This is our memory within our computer. And we've got, let's pretend, each little slot represents a certain amount of bytes of data. Let me build this out. I just need to make a quick grid. I know those aren't straight. They're not going to be even, but that's okay. That's not really the point. Cool. One more. Okay. Let's use this as our sort of base. Let's pretend, I'm sorry, this is going to drive me crazy. This is awful. This one. Unreal. Okay. Let's do this. Sorry. And hopefully that also was bothering other people. Because that one was just bad. Albert, I could see it was bothering you too. So, okay. So let's pretend that this is our memory, right? Where we are, this is our computer. And so we are starting to save some information. And each of these represents, 8 bits of data or 2 bits of data. It's sort of just how much memory each one costs, right? Each one of these is a memory slot. The way that an array works in memory is, let's pretend I've got an array of 1, 2, 3, right? And let's say that I want to say, let X equal 1, 2, 3. Well, what our computer is going to do is, let's say that I've got some piece of information here, and I've got some piece of information here. I'm already, let's say I saved a name or something. It's going to go find in memory consecutive amounts of memory that are big enough to hold all of these, pieces of information. And so maybe it says, oh, okay, great. This is a name. This top part's a name. This is, something else. Doesn't know what it is. It's just taken up. But I see right here, let's pretend each 2 of these represents one number. So I have 1, 2, and 3. Cool. All of this is my storage that I'm taking up, right? And saying, okay, great. I found a piece of information. We're good to go. Now let's hypothetically say that I want to now add in a new value, and I want this to move. And I want to add in, and I want to push the number 4. And put this in green. Maybe I want this to be the number 4. Well, what a dynamic array does, and this again, this is a JavaScript and Python. They use dynamic arrays. Java does not. What a dynamic array does is it'll say, okay, great. I need to insert something, but my memory is already taken up, right? I'm at the end of my list. It's only allocated at this point. It's only allocated for, 1, 2, and 3. So what it'll actually do is, instead of just adding in the 4th value here, right? What it'll actually do is it'll say, well, okay, I have 3 values in here. I need to add in a new value. I am going to create space. And what it actually does is it doubles in size. It doubles in size. So it then goes to, here, because there's going to be 4, 5, and maybe here, right? So now it has room for 3 more values. So instead of it just taking up from here to here, or adding in just 1 more value, even if we are just adding in 4, it's going to take up all this space as well. And so it keeps doubling in size, right? As long as there's consecutive space, right? If there was a value already here, then it would say, oh, I can't take that piece of information. I can't, you know, there's not consecutive space. Let's say that something was already right here. They say, oop, and it would move the entire thing and it would find consecutive space in memory for it to move this array. Now, that can be pretty costly, right? And if you think about it, great. We have added in space for 4. Let's say we add 5. And then, oops, we added 6. But now I want to add 7. What do you guys think it does? Do you think it just adds the number 7 here?
Is it gonna pop in?
Doubles the whole thing.
It doubles the whole thing, right? So now, instead of having 6 spaces, if the 7 is no longer there, it's now going to have room for 12 spaces. And you can see that it starts taking up quite a bit of information. If I've got, you know, if I keep going, and it can kind of infinitely keep growing that way, and it just keeps doubling itself, right? It's dynamic, so it means it's adjusting. Now it doesn't, you know, if I delete stuff, if I delete spaces, it doesn't go down, right? And say, oh, well, I don't really need that anymore. It just kind of keeps it there. The good news about that, or some of the power behind that, is adding in something to an array. If we are inserting into array towards the end, if we're inserting in the end, can anybody guess what kind of time complexity that would be?
O of n. It depends on how long it is. Because you gotta
O
get
of
to the
n?
end every time. You gotta go through all the way to the end.
Sure, but if we're just adding to the end,
Oh, it'd be O of 1.
it's O of
You're just
1,
doing one
right?
thing.
And if we're dealing with space complexity, it's O of 1. And you might ask yourself, well, why if we're just adding and taking up more space? And it's because there's like a mathematical term that talks about it is, yes, in the moment that we are doubling the size, that is an O of n, right? Because we need to know how much. But every single moment after that, if I'm just adding in a new value, I already have that space allocated. And so the amortized time, or sorry, the amortized space complexity of this is O of 1. Because even if we get to, you know, 64 values, we're taking up 64 bits of data, and I need to go to 132 or 100 and what's that? 128, sorry. Once I do the 128 for all of the values between 64 and 128, it's just already, you know, we've already allocated that space. And so, and then if I need to go even more, then I've got what? 256. Right? And then I keep going to 512. And so, yes, I'm doing a calculation, or I'm having to increase my space, you know, 1, 2, 3, 4 times. But that's only happening for, you know, we're only doing this 4 times between the numbers or the amount of information from 64 bits to 512. So all of the space, or all of the operations in between that is just O of 1, right? Because I'm just adding into a space that's already there. So this is how a dynamic array works. Why am I telling you that? Well, because the power of a singly linked list is because it works differently, right? A singly linked list, I'm going to move some of this, I'm going to kind of write this down here. Or just linked list. There's something called a doubly linked list. We're going to talk about singly first, and there's called a circular linked list, but we'll start with singly. Is I can take data, and let me actually delete all of these, because it'll make it a little bit easier to understand. Sorry for the OCD kicking. I know it's awful. I did my best. Okay. A singly linked list is where we could take something we call a node, and that's just representing a piece of data, right? And let's say I've got the numbers going back to our original of 1, 2, and 3, where I have this node of 1, and we have something called a pointer to another node of information. In this case, it's 2. And then 3. this is a visualization of how a linked list works, right? You have one node that points to the next node, that points to the next node. Now, the power behind this is, let's say, again, each of these takes up 2 space, each number, but space is a limited resource, right? Space is a limited resource on my asset. So what I could do is maybe I've got 1. So maybe the 1 takes up this space. And then maybe there is something all the way to here. And there's something right here. There's all this information. Let's say, for example, all of these squigglies represent taken up space. What I could do is I could have a linked list allows me to put a 2 here that represents this, and then a 3 here that represents this, right? Or that represents the 3. And then I just have a pointer that points to this space in memory. Each one of these would have like an actual memory address, right? And then my 1 points to my 2. Maybe let's go back and do this in new color for my pointer. My 1 points to this part of 2. 2 points to 3, right? And so what's different than the array is I don't need consecutive space in order for this to work, right? I don't need to have, hey, this all has to be perfect or else I've got to copy my array and put it other places. I can just fill in my data wherever there is, I can add in data wherever it is. And then I can just change my pointer and everything's good to go. Now, what's nice about that is when we're dealing with arrays have a lot of power. So I'm not just trying to like say arrays are bad, but when we're dealing with arrays, when we are inserting into the middle of an array, it is an O of N operation because maybe I'm inserting or here, right? I have to make a copy of the rest of this. And then I add in the value and then I add in the copy here. And it's a pretty timely, from a time and space complexity, it's a pretty timely operation. Whereas let's pretend I did have one more space available. Maybe it was like right here. Let me get my pink out. Maybe there was a space right there. And I wanted to insert the number 4 to where all of a sudden, instead of it being 1, 2, 3, it was 1, 2, 4, 3. Oh gosh, what is happening? I want it to be 1, 2, 4, 3. With an array, we'd have to basically slice it, make a copy, then add them together. Here, if I've got the number 4 that I'm wanting to add in, all I do is I change my pointer, and this is all happening under the hood, and this is sort of just the power of why this is working, or why a singularly linked list is powerful, is instead of my pointer being to 3, I just change where it's pointing. And then this can point to 3, right? And so it's really malleable. It's really, really like from a memory perspective, it's really beneficial because you don't really have a ton happening, right? Or in the sense of you don't have to make copies. You can just, it's really malleable, right? Really mutable. Think about like a randomized song playlist. You have one song and then you have the next song and the next song. This is a singularly linked list, right? It's a great example of what a singularly linked list might look like in the real world. Does that make sense? Are there any questions on that?
I got a question. So, the graph kind of lost me. So I guess, so when you're doing, I understand that with the first example, you had like a normal array, and you would have to just basically add on to the end or change one value, and this allows you to change a specific spot. But I guess where I'm confused is, so we're going to be writing some sort of code that allows us to, I guess I'm trying to visualize that. So would it be like, all right, this singly linked list
Mhm.
at the position of 1, which in this case would be the number 2,
Mhm.
right? So we can change that to something, and
Yeah,
I guess I'm trying to
So-
see how that's different from a normal array.
yeah. So array, remember, and this is just I was hoping I see a couple people. I might have lost you, so I'm hoping that we can sever this. The idea is that in memory, if we're just TLDR, right? Too long didn't read. In memory, when you have an array, it has to have consecutive slots of memory in order for it to hold that array. With a linked list, it can be a node or a piece of information. This is just a visualization of your memory in your computer. Each memory has an address. So it'd be like, address, 105, right? And 106, 107, 108, something like that, right? This is
Mhm.
just the power is instead of it having to be consecutive, it can just pepper in wherever there's an opening to a value. And then we just create a pointer to the next value. And you're going to see we're literally going to use the word dot next. And it's going to say, okay, this is making a pointer in memory to, hey, the next value after this memory piece, it's going to hold two things. It's going to hold the value. So in this case would be 1. And the dot next, it's going to hold a next value. And in theory, it's going to be the place in memory of this. Which
Oh,
is
so
just
there's
a
not
node.
actually anything there. You could just later on.
Mhm.
Oh, okay. I think
Yeah.
okay. I think it'll make more sense when we do the code.
I think when we
That
actually start coding it out, it's going to make way more sense. I was just trying to tell you or show you guys, hey, maybe in memory, this is why, because it's easy to be like,
Gotcha.
well, why wouldn't I just put this in an array? But just to show you, hey, visualization wise, this is what's happening under the hood. And this is where the power, this is really the power of a singly linked list is in memory. It's much faster. It's much easier to store things. It's much faster to grab and retrieve things.
Okay, and this would be like the computer's doing. Okay, I see you
Yeah,
now.
your
Okay,
computer's doing all the heavy lifting. We're
thank
not
you.
actually
Yeah.
pointing to this is the address in memory. It knows what it is because anytime we create like a variable, right? If we just create the variable X, it's creating it and it's saving it in memory and it gives it an address. We don't have to know that. We just say, hey, point to X.
Okay.
And it goes, oh, okay, great, cool. X has all these
Okay.
properties associated.
I got you now. Thank you for
Yeah.
explaining on that.
Yeah, of course. Habtamu?
Okay, my
It doesn't
question,
have to be memory available.
Oh, sorry, Dentro. Give me 1 second. Go ahead, Habtamu.
okay, my question may be answered during the coding review, but I'm kind of confused with this time complexity, space complexity, array versus single list. When you
Mhm.
mentioned like the array X first hold 1, 2, 3, and then when we add a new element, it doubles the size.
Mhm.
And then the time complexity and the space complexity is like of 1. I'm not sure or how that is, and I don't know about the sync list, but maybe like that would be
Yeah, let's give it some, let's code it out and then we can kind of go back to the array complexity if there's still some questions there.
thank you.
It's a mathematical and I can send you some information on it too. And if it still doesn't make sense, we can go through it, in office hour. But it's just an amortized time. But we can go through that. It's a little bit more heady in the clouds. I just
Did
wanted
we-
you guys to be familiar with that because I think it's an important thing to know.
Okay, did we talk about the space complexity last week?
We did.
We did?
We talked
Okay.
about time and space complexity on the office hour of Thursday.
Officer. Yeah.
Did we have a recap for that? Like, I think I missed that.
I can send you the link. I just watched it.
It's in
It
the
really helped.
It's
Thank
in the let me get
calendar.
out of this. Yep, in my calendar. Oops, sorry.
On the calendar,
Big O notation right here is the YouTube video. It's
Where?
45 minutes long.
oh, like that attached to the calendar, or is it like a
Yep,
plate?
so it's on the calendar. Sorry, let me delete this stuff. On the calendar, last week, this Big O notation.
Oh,
It's 45 minutes. Walk through
I
with Big O
haven't
notation.
I just put it in the chat.
Yeah, perfect. Thanks, Colin.
thank you. I haven't refreshed that way. All right, thank you.
Yeah, that might help give a little bit more of an understanding of time and space complexity.
All right, thank you.
Cool. Yeah, of course. Okay. So what does this all mean? Well, let's build out a singly linked list, or sorry, Dontrell, did you have a question real quick? Sorry, I cut you off, I know. Okay. Let's build out a singly linked list. We'll build out all the
Sorry, it wasn't,
pieces.
I couldn't find it, but it wasn't a real question. It was just as long as there's memory, then we're good. It does the rest. Is what I was saying. It's
Yeah.
fragmented pieces being glued together.
Yeah, yeah. You should be good. Again, when we're dealing with like IoT stuff and memory is really important, that's where you go through it, but that's down the line. You guys don't need to deal with that right now. Okay. So again, we talked about a singly linked list, and if you go onto the platform, there's a lot of stuff about objects and classes, which is what we talked about last lecture as well. It talks about the pointers. This is an example of a memory location. And so this is what it might be. Again, there's properties when we create a variable or we create something, an array, a dictionary, something, it's going to have a memory space of where it lives. So that's just like a fun example. But when we're dealing with linked lists, again, we sort of think about this circular visualization is a really easy way to understand a linked list, right? Where we've got 3 circles, and these are what we call nodes, right? So I know for the OCD people, I'm killing you. I'm sorry. But we got these nodes, and the power behind them is they have pointers, right? So this node points to here, and this node points to here, right? Well, this first node, we consider the head. And so this first one here is going to be the head. This is the beginning of our singly linked list, right? The remainders are just different nodes. Now, when we are dealing with a doubly linked list, which the only difference behind, or not the only difference, but the difference behind them is a singly linked list, you can only traverse one way, right? So you can only go from this node to this node. You can't go backwards, right? Think of back in the day, Pandora, right? Back in the day, Pandora, if you really liked a song you listened to, you couldn't say, I want to listen again. It was just on to the next, right? Spotify, you can go and you can repeat. And if you're like me and you get a song, you will listen to it until you hate yourself and that song, right? And so they have something called a doubly linked list, which is a pointer back to another value. So you can traverse from one node to another. Think of, oh, I listened to this song. I loved it. Another song started. I hated the song. I was really into the other song. So I'm going to go back and I'm going to restart, right? That's a doubly linked list. So you can go forward and backwards, again, just like Spotify. And that might have something called, or that has something called a tail, which is just the end of your linked list, your doubly linked list. For what we're dealing with, we have head and nodes for a singly linked list. We don't deal with a tail. Cool. But this is a great sort of example of these. And if we were to have, the last thing I'll say is, let's say we hypothetically had, okay, head, tail, and there was a pointer that pointed to here, right? And here, then that's what we call a circular, right? It just sort of, you can traverse the entire thing. You don't have to go through each one, but you can go from the head to the tail, sort of the whole thing. To sort of think about like repeat, right? If your Spotify's on repeat, it goes through and then it starts again. And it goes through and starts again. Circular linked list. We're only dealing with singular for right now. Okay. So those are the main pieces, right? Our nodes and our head. So when we're dealing with nodes, or we're dealing with singular lists, similar to what we talked about, is we have to create a class, right? We create a class for our singly linked lists. And so I'm going to create a class called node, right? It's going to have our constructor, which we recall is our, when we call this class, we create a new instance of this class. This is what runs. We have some value that we're passing in. So what is that node's value? It can be a string, it can be a number, it could be an array, it could be an object, it could be anything. We're going to use numbers because it's easier, but we have access to that. So what is the value of the node? And then can anybody guess, what does the this.next mean? What do you guys think that means?
That's the connectivity to the node, right? The pointer.
Yeah, it's the pointer. That's exactly right. This is the pointer, right? The dot next is the pointer, and it's saying, hey, go to this value in memory, or go to just this value and it's going to have a memory slot allocated. So this dot next is my pointer. Great. Cool. So I could say something like let node 1 equal new node 2, and oh, I was fast, 3, right? Cool. So I've created 3 nodes. I've got 3 just circles chilling, right? That aren't doing anything, right? This is just 3 pieces of information. And so if I want to create a linked list, I can do that, right? I can do that. Before that though, how can we attach these together? What do you guys think? Just with this now, before we even create another class for singly linked lists, how could we attach these together? Yeah, I see it in chat. Tamu,
Okay.
is the dot next, right? So after I've created these, what if I said node 1 dot next equals node 2 and node 2 dot next equals node 3? Now what this is doing is I still have my 3 circles. And this circle, let me actually make this bigger because I want to write in it. So I've got 3 big circles. This is my node 1, 2, and 3. It's going to have 2 pieces of information, right? The data itself and the next value. The first one, so I'm just going to put D and N because it's faster. But the data is 5. And then the next value is node 2. And put N2 for that, right? But it's the pointer. It's pointing to this entire thing, whose data is 10. Its next value is N3, whose data is 15. And its next is, can anybody guess? Because it's the end. What do you guys think will
It'd be
be?
null.
No, exactly, right? Meaning, hey, there's no value there. And so now I've created a singly linked list, right? I've done it the hard way, where we're going to show how we can actually create a singly linked list, create a class for that. But I've done it the hard way. I've connected 3 pieces of information, and I can handle it however I want, right? If I wanted to change that, let's say I created a 4th node and I wanted to change my node 2 to point to that, well, all I have to do is say node 2 dot next equals node 4. And then maybe node 4 dot next equals node 3. And now you can see I didn't have to touch node 1 dot next, but I could go in and I can just alter it, right? Any questions on us creating this at the beginning? Anything that doesn't make sense here?
So it has to be serial, like can node 2 have like 2 other nodes, like node 5 and 6 from node 2?
No, that's what we call a graph or a tree.
Oh,
Like a
graph.
binary, yeah, that's a graph. So this is a totally different data structure. But yeah, a graph would have like, you have a node and then it's got 2 nodes, and then you got a node and then it's got 2 nodes. And then it
Okay.
can even just have 1 node here. That's a graph. And then this doesn't even have to have anything. And that's where, that's a data structure. It's a great idea, but no, that's a totally different data structure.
Okay, thank you.
Yeah, of course.
So in
Great
this in the singly linked list, you can only go one direction, right? You say you
Mhm.
can traverse only 1 to 2. Well, you can only go up, right? So if we
Mhm.
wanted to go backwards, you would have to have a doubly linked list.
Mhm.
Is that correct?
Exactly. Yeah, and really think about it. We have a dot next. What if I had a previous, right? The previous node, and it was just a pointer to the last value. So N2.
Is that a double linked list?
This would be a doubly linked list.
So
Yep,
there
and
is a
then maybe
previous keyword.
no,
Yeah.
previous. These are all just data dot next. It could be value. It could be, it doesn't. This is what it's pointing to. It's just pointing to the next value. This could be unicorn and cupcake.
So in order to make it work, would you have to add in the constructor this dot previous?
In my constructor, yeah, if this was a doubly linked list, I would have, you know, this dot previous. We don't need to do that right now. That's down the
I got
line,
you.
but yeah,
Sure.
that's all you would do.
Thanks.
And then there's a couple other things. Yeah, of course. Any
Is
other
this
questions on
something-
this?
Is this something like similar indexing, like index chart, a pointer node as index?
No, not really, because an index is a sequential thing. So if we have like an array with an index of 2, like it's a sequential, and again, the power of a singly linked list is this memory location or this next, which contains that node, which part of the property is the memory. It can be anywhere, right? So it's not a sequential thing, and it doesn't have to have that value either.
Okay, okay.
Sorry, I got one more question. If you wanted to have let's say we got 3 nodes, do they all have to have a value, or can you have one with no data in it and 3 with data in it, or do they
You
all,
could-
in order to make the next one,
You could
have to
have, well, you could have, you wouldn't necessarily want to just take up space in memory if it didn't have data. You would just add it whenever you needed it, right? And so
Okay.
if it was null, then you could
This
just
is
not have it.
tomorrow.
If it was just null, then you could just not have it.
I need tomorrow only.
Okay.
Yeah. Dontrell, I'm gonna
thanks.
mute you. Okay, cool. Now let's think about this. Let's pretend with what I've created so far that I want to iterate through all of my nodes and I want to show their values. I'm gonna turn off Copilot so that way it doesn't. How would I do this? I have 2 ways I can iterate. What are my 2 ways I could iterate? 2 foundational ways. We've talked about both. Yeah, I've got a for loop
And a while loop if you wanted.
and a while loop. Can anybody tell me when would I use one over the other? What's the big thing I said? Why would we use a for loop? Or when would we use a for loop?
When we know,
When we
like,
know the ending.
Exactly, right? I don't know how long this list is going to be. Right? It could be 10 values. An album could have 50 songs. It could be a greatest hits, or it could be an EP and have 5 or 6, right? So when we're dealing with singly linked lists, a while loop makes the most sense because we don't know when it's going to happen, right? So if I wanted to iterate through this entire thing of just what we created so far, what could I do? What do you guys think I should add? Or what would I do here? How would I iterate through this? Let me make a visualization, but I want you guys to, I want to go from here to here to here. And I have data and next in each of these. So what could I do? I want to start from the beginning and move to the end.
You could write a function
We're gonna write a function.
that has a while loop. I don't remember how you start a while loop, but
Is it
a
while
function.
this dot next does not equal null?
Yeah.
Something like that.
Yeah, you're right on the path there. You're right on the path there. Let's think about this. If I want to start at the beginning, remember for a for loop, we have our index position, right? Where do we want to start? So here, let's indicate where I want to start. Maybe I'm going to have a value called current, and it's going to be node 1. Right? I want to say I want to start at the beginning. Again, we don't have a singly linked list yet. We've created one. This is kind of the hard way. Then we're going to actually create a class for singly linked list. But we're sort of bootstrapping one right now. I say, okay, I want to start here. And what do I want to check to make sure that, hey, is there even a value after this? Or what'll be an indicator of when I would stop my while loop? So let's say while.
You could do while the node is not null.
Yeah, right?
So
I
like
could say something
exclamation,
like while current does
exclamation.
not equal
Yeah,
null.
we're gonna do something.
We're going to do something, right? Maybe I just want to console .log. I just want to get the value. Current dot data. Right? I
Yeah.
just want to get the 5, 10, 15. Now, what's the big thing I have to have when I'm using a while loop? What do I have to have or else I'm gonna break my computer?
Move to
Make
the
sure
next.
you stop it.
I gotta move, right? I gotta iterate, I gotta move. If I'm stagnant, then I'm always gonna run and I'm gonna break my computer. So with what we currently have, current equals node 1. So if we're thinking about node 1, what could I do? What is my
Like
mover?
current dot next
Current.
think.
What if I reassign current
Plus plus.
to current plus plus would just add on a 1, right?
Oh, yeah.
okay.
Current dot next. Yeah.
But I say current.next. So now I'm saying, okay, hey, as long as current is not null, then I want to go in and I want to print the data. So we're going to start here. It's going to print 5. It's going to console log 5. Then it's going to say, well, now my node, I'm going to move from here to here, right? Current to current.next. Current.next is node 2. So it's going to go to node 2. And it's going to say, hey, are you null? Well, it's not, right? There's a value there. Cool. Let's console log that value. Now I want to say current equals current.next. So I move from 2 to 3. It's going to say, hey, are you null? Well, no, because there's a value there. It's got some data in it. And then we're going to console log it. We're going to say current equals current.next. Current.next by default is null. And node 3 doesn't have a pointer. So then my current is going to become null.
It'll
It's
stop.
going to break my while loop. And then I'm done, right? So if we were to run this, we get 5, 10, 15. We iterated through each one. Now I just want to show you, this is what it looks like. If I just say current, then I'm going to show you the actual node. Now, the other thing I could do is I could say current.data because it's doing the same thing, but this is a falsie for JavaScript. So because it's already null, it's going to just break. But if you would have thought, oh, why wouldn't you do current.data? You could do that and it work just fine. But I just wanted to show you, what does it look like when we actually deal with, or what does the actual node itself look like? Well, here I have my node with the data of 5. It's got a next value, which is of class node, that has data of 10, who's got a next value of a node with data of 15, that's got a next value of null, right? So all of this is stored in each node.
That's a circle.
This isn't the circle, because the circle would be that if node 3 then pointed to, if it added this dot next to node 1, then it'd be a circle. But then this would also never end. So I would.
Well, I
break
mean
my
the
code.
circle you drew. It's got each
Yeah.
node is a circle and it's got
Yeah,
data
sorry.
next.
Yeah, sorry. I thought you were saying a circular list. No, you're exactly
Yeah.
right. This right here represents this whole thing right here that I've highlighted represents this entire circle. Right? Then this right here represents this entire circle. And this whole first portion represents this first circle. Right? So the first circle, the second circle is this whole thing, and then the third circle is this whole thing.
I like the train analogy with this because it's like you have a train and you're telling Mitchell takes everything literally to run down the train until he finds an empty car, but
Mhm.
don't stop at each one and just sit there.
Yeah.
Hey, Will, the only thing I'm confused about is how it knows to go from node 1 to node 2 when it goes next. Maybe I missed that part.
Yeah. So great question. When we constructed our node.
Oh,
from our
I see it right
class,
there. Okay.
Yeah,
Okay,
we had a
cool.
property of
It's on
.next.
12 and 13. Okay.
Yeah, and so we actually just made those values here and said, okay, let's reestablish. Okay, when we created it, it had a null value. If I didn't have this, and I were to run this, I would just get the first one. Right? Because it ran the node that had some value, it had data. But then once this dot next by default is null, so then whenever it increased current equals current dot next, it went to null and then it went out, right? So this is my pointer. This is saying, again, this next property is my pointer.
Mhm.
And so it's saying, okay, point to this node and then point to this node, which we see
Okay,
here.
cool. Thank you.
Yeah, of course.
So
Good question.
what line number 12 and 30, what is this called? Like these two line.
These two lines.
Huh.
It's creating our pointer, but it's not anything. It's the same way that if I were to have like, we're just dealing with classes. I'm just assigning a value, right? It's just dealing with a class. This is a class attribute. So I have an attribute of that specific instance, and all these are doing is this is manually saying, hey, add in where this attribute of dot next is. Again, this could be called unicorn, where dot next is or dot unicorn is. I want you to put this node here. This is a manual way to do it. We're going to actually create a singly linked list value, and then tomorrow we'll create a singly linked list class, and then we'll be able to see how do we add to stuff, delete from stuff, and sort of like build out a legitimate and operate with, if we're dealing with a Spotify, how would it, okay, we make a request, we have all these songs, let's add them to a list, right? Just do that.
So these are like the main thing, like this is what the single linked list did, right?
Yeah.
Like node 1, 2, 3. This is how they linked each other. Node 1.
Yes. This is the link, right? Yeah. This is the link. This dot next property is the link to the next node.
That makes
It's
sense.
it's the link to the next node. This is, remember when I had my whole grid, I won't do it again, but let's say I had my whole grid and I said, oh, okay, it had, oops. So it went there and there. And I said, oh, here was number 1 and here was number 2. And there was a pointer that said, hey, I want you to go from here to here. This is that pointer. There's just a property here, just like we saw right there, that points to this node right here. Versus it having to be like 2, 3, 4, whatever. It could just be anywhere. That's what this next is. This is my pointer.
So
That makes-
that like, when we add an element in the array in between, so we're gonna do that kind of demo tomorrow, like
Yeah.
as we started from the earlier, like array, add element in between. So
Mhm.
it's
Yeah.
more.
All
okay.
we do, let's pretend, I've got a, let node 4 equal new node, we'll keep with the theme. Well, let's pretend that down here, I want to change it to where, node 2 no longer points to node 3, but I want it to point to node 4, and then node 4 points to node 3. I could even just say node 2 dot next, because it's just a property. Node 4 dot next equals node 3. Right? So it's really easy just to say, oh, instead of pointing to here, now I want you to point to here. Really, really easy.
That's why you would want to use a single use list, because you could just change it.
You can just change it in the middle. You just change
Now
one
it
thing,
makes
but
sense.
1 isn't touched and 3 in theory isn't touched, right? Because node 3 was never pointing to anything anyway. It was always the end, but now I've added in the middle, but I don't need to touch the first 2 nodes. I just need to change the pointer.
Wow. I get it now.
Yay! I love that. We're going to talk a lot more about this. So if you're like, I don't love this, this is just the beginning. this is what we're talking about for the next couple days. So, in fact, I think it's all 3 days. So we're trying to go, we'll go slow. Yeah, we're just going to keep with singly linked lists. We're going to talk about how do we add to the middle, add to the front, and just manipulate singly linked lists. Then maybe on Thursday, if we have time, maybe we'll go through some doubly linked lists. Just show you. We'll do singly linked lists tomorrow, and then doubly linked lists and how we can adjust with that. So that's all I've got. I'll stick around if there's any other questions. Other than that, I hope you guys have a wonderful night, and we will see you tomorrow. Don't forget to send me your group stuff if you need it.
Okay, thanks, Will.
Thanks, guys.
Thank you.